Welcome to example 6. This is a question that involves vector components. So suppose you're doing some daily exercises, and this is your arm here, and we would like to know the force F broken up into X and Y components. So we're given the force along this deltoid muscle is 270 newtons at an angle of 15 degrees above this horizontal. So one of my first steps that I will do is to draw out the vector, and I'll draw it over here just to have a neat diagram. So there's my force of 270 newtons. The next thing I will do to my problem is I will show a x and y coordinate system. So moving along the right direction would be a positive x-axis, and moving up would be along the positive y-axis. Next, we're going to take this vector and resolve it into its x and y components along each of these axes. I've drawn two parallel lines to each axis at the tip of this vector, so I can appropriately show the y component and the x component of this force F. We also have this angle of 15 degrees with respect to the negative x-axis. Now, just to help visualize this, I'll make this into a right triangle. So I'm going to move this force over here and create a triangle with this. We know that the resultant, or the hypotenuse of this force, F, is given as 270 newtons, and the angle is 15 degrees. And we're trying to solve for Fx and Fy. Now think of an appropriate trig function, remember this is a right angle in here, that would involve, for example, fx and f, and the angle, or fy and f and the angle. Hopefully you're thinking of sine of the angle would be one of them, which is the opposite to the angle of 15 degrees, which is fy, all over the hypotenuse, which is f, or you can rewrite that as sine of 15 degrees equals Fy divided by 270 newtons. And if you solve for Fy, it will be 270 newtons times sine of 15 degrees. And this will give you an answer of 69.9 newtons. Then we can also determine the x component by, say, using cosine theta, which is the adjacent side, f sub x, divided by the hypotenuse, f. And then we have the cosine of 15 degrees, which equals fx, divided by 270 newtons. Therefore, the x component is 270 newtons multiplied by cosine of 15 degrees. I guess we could put newtons here as well. And so our x component force is going to be 261 newtons approximately. But I do have one tiny little error, but it will be very important when we are adding vectors. You see, the y component of this force points along the positive y-axis, but the x component points along the negative x-axis, so this should be a negative force. So therefore, we have F sub x equals negative 261 newtons, and the y component will be equal to positive 69.9 newtons, the way we've defined our x and y axes. If we were simply just asking for the magnitudes of these forces, we would just simply want the numbers. But if we were asking for the x component and y component vectors, then we should be including the signs. Okay, and that's it for example 6.